Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on October 16, 2025, just yesterday. The striking result is that with only 1,000 reinforcement learning samples, QN314B using AEPO hits pass at 1 of 47.6% on GAIA, 11.2% on Humanities Last Exam, and 43.0% on WebWalker, and pass at 5 of 65.0, 26.0, and 70.0%. The paper is titled Agentic Entropy-Balanced Policy Optimization, and as we will see, the implications for agent training are quite significant. In short, this paper balances entropy during rollouts and policy updates to avoid collapse and clipping, while boosting rollout diversity and keeping policy entropy stable. Also, the authors shared a GitHub repo. You'll find full ARPO and AEPO code, ready to run training scripts, configs, and requirements, SFT via Llama Factory, RL pipelines with tool call integration and search cache, evaluation and VLLM inference setups, datasets and pre-trained checkpoints, plus utilities to convert VERL checkpoints to Hugging Face formats. On Hugging Face, you will find AEPO-tuned QN checkpoints with 8 billion, 15 billion, and 8 billion parameters, safe tensors downloads, plus Python snippets showing text generation and chat inference. Alright, Figure 1 shows that the method delivers broad gains across web search and reasoning tasks. The left bar charts compare deep information seeking, where QN314B with the approach reaches 65% on GAIA. On Humanities Last Exam, the model reaches 26%. On WebWalker, it achieves 70%, which signals strong gains against larger baselines. The right radar plot summarizes generalized reasoning, showing consistent dominance because exploration and updates are balanced, and these gains come with only 1,000 reinforcement learning samples. So, Figure 2 shows why naive entropy guidance backfires for web agents. Entropy here means the model's uncertainty over tokens, which spikes around tool calls. The left panel depicts rollout collapse, where consecutive high-entropy steps trigger branching on one path, so exploration of other branches stalls. The right panel illustrates policy updates that zero out gradients on high-entropy tokens, which prevents learning exploratory behaviors. AEPO targets both issues by balancing branching and preserving informative gradients. Alright, Figure 4 presents the full AEPO workflow and how entropy is balanced across rollout and updates. The top pipeline routes a question through the policy model and tool environment, then scores outcomes with a reward model, so training favors informative actions. Panel A estimates token entropy at the root and at tool call steps, using this gap to set how many global versus branch rollouts to sample. Panel B guides branching with a penalty on consecutive high-entropy nodes, which limits overbranching and preserves diversity. Okay, Table 1 reports head-to-head results on deep information seeking, showing that AEPO consistently tops both single-enhanced and reinforcement learning baselines. On GIA, QN314B with AEPO reaches 47.6%. On Humanities Last Exam, the model records 11.2%. On WebWalker, it achieves 43.0%, which signals strong generalization across multi-step web search tasks. So, Table 2 shows that the method delivers stronger generalized reasoning because it maintains exploration during training while keeping gradients informative. The upper block with Llama 3.18b instruct reports the best averages for the entropy-balanced approach, edging past GARPO and the clipping-optimized methods. The lower block with QN 2.57b instruct repeats the pattern, with the entropy-balanced approach leading by several points on average. Together, these results indicate stable gains across architectures. Alright, 2 takeaways stand out. Balancing entropy during rollouts and policy updates prevents branching collapse and preserves informative gradients, and this yields strong gains with just 1,000 reinforcement learning samples while reducing unnecessary tool calls. The broader implication is data-efficient, scalable training for web agents that generalize better across tasks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.